Alright, hello everyone. We are going to study physics today. Alright, so you just started physics and you're about to study dynamics, which makes up 2/3 of what you're going to be doing in AP Physics 1. So, what is kinematics? Of course, it's just the study of how objects move. Really, it's not that difficult. But if you take a look at it, it actually has a bit of confusing topics. So let's see what kind of confusing topics that the College Board will test you on when the AP exam actually comes. So let's take a look at this FRQ that I made. It's not really an FRQ, but it comes close to one. Alright, so it says, an object of mass 2 kilograms is launched at an angle of 60 degrees above the horizontal with an initial horizontal velocity of 6 meters per second. So there are technically 6 parts to this, because C has 2 parts. Actually, no, 5 parts. But we'll say that the 4 are there, and we'll just tackle one part at a time. So, find the other initial velocities, find the apex height, find how long it takes to reach the apex and first contact with the ground, and of course, finally, find the total displacement. So let's go through what's important here and what's not. So if you take a look at this, you'll see that this says right here, mass of 2 kilograms. Honestly, if you're studying a Kinematics question and you see this come up on a question, the best thing to do is to just rule it out. Because honestly, this is definitely not something that you will be using for a kinematics question. It's used there, it's put there to trick you. Mostly that's used in forces, but of course forces isn't kinematics, is it? So, they did not provide you a drawing, so how about we start with making a drawing first. They said that the object is launched from the ground 60 degrees, okay wait, that's pretty bad then. So how about we make it 60 degrees. So they said that that's 60. And they said that it's launched with an initial horizontal velocity of 6 meters per second. So if you put 6 meters per second here, we can start doing trigonometry to find the other sides, which is part A. So, what's the initial vertical velocity? Well, you know that this triangle is a 30-60 degree right triangle. If you don't know that, you can go search another video up. It's pretty simple. Or if not, you can just use a simple formula here. It's simply tan of 60 degrees is equal to whatever this length is, we'll call it x for now, divided by this. And this is of course because tangent is equal to the opposite over the adjacent. If you don't know that, go search up trigonometry basics on YouTube or something, because it's actually a fun topic. But yeah, you can't cover it here because it's a bit of a wide kind of topic to study. But if you calculate this, you'll realize that you get that this side length is actually 6/3 meters per second. Of course, the College Board is going to ask you to calculate that and make you a decimal, but we're not going to do that here to make this a bit more simplified. But yeah, 6/3. Then you can essentially do the same thing here, or you can just Pythagorean theorem it. You can search that if you don't know that. But the answer you get here is 12 meters per second. So you know here that the initial velocity itself is 12, and the vertical is of course 6/3 meters per second. And you can just plug that into your calculator to calculate what that is, and round to 2 centimeters. Don't know what that is? Well, you can go search that up as well. So we'll keep the drawing for now. But, alright, we'll go on to part B now. Find the apex height. Okay, so, what exactly is the apex? So, apex is just a fancy way of saying find the maximum height that the object reaches. So how do you find the maximum height? It's actually quite simple. Simply just plug it into one of the kinematic formulas, which we could think of as change in x is equal to v naught t plus 1/2 at squared. And of course, I encourage you to pause this video to just see how to do this on your own. If you don't know it, of course, just unpause and then just look at how we do it now. So, we know that our initial velocity vertically is 6/3. And then we also know that our acceleration downwards is just the force of gravity, which is 10 meters per second squared. of course, we're going to say that it's moving downwards, so technically this should be negative. Which means that, technically speaking, we should not be using this formula. Sorry about that, I did not see that properly. But, so the first thing you should do when tackling questions like this, like these, are just like, try and figure out what values you know and what you don't know. So you know that your initial velocity is going to be 6 root 3 meters per second, and you know that your acceleration is going to be downwards 10 meters per second squared because of gravity. And since it's downwards, which is the opposite direction of where we're going in, it's going to be a negative. So what else do we know? Of course, we know that since it's going to be at the maximum height, the object is going to rest momentarily at the top. Think about it like this. The marker temporarily, even for just a moment, stops, which means that our final velocity is going to be 0. So what are we trying to find here? Of course, we're just trying to find the maximum height. So you can also use the third kinematics equation, which is just v squared is equal to v naught squared plus 2 times the acceleration times your displacement. And this is what we're going to look for. So here we can just plug in values. It's pretty easy. We know that the final velocity squared, well, that's just 0. Pretty simple, right? What's our initial velocity squared? Well, that's just 6 squared, which is 36, times the square of the square root of 3, which is just 3. So that's just 36 times 3, which is 108. Let's see what else we know. We know that our acceleration is negative 10, so this is just plus 2 times negative 10 times what we're looking for, a change in x. Of course, your paper's probably not going to be as messy as this board is, but, you know, it's just messy. So you can just move this over to the other side to get that 20 change in x is equal to 108. Which means that you get that your displacement is just 108 over 20. And if you plug that into a calculator, let's see, that's just 5.4. So your apex height is going to be 5.4 meters. Pretty simple, right? Yeah, it's not that hard. Alright, so just to clear up some space, I'm just going to get rid of this picture because I don't think we're going to need it anymore. Hopefully you understood that part A. And we're going to get rid of this as well, because we're not going to need this either. Alright, so they're asking for how long it takes to reach the apex and how long it takes to hit the ground for the first time. So because this is just two-dimensional motion, we know that there's no friction involved because they didn't really specify it. If it is involved, you're going to have to go deeper into the study of forces, which we'll be going over in the future. But, so they asked you how long it takes to reach the apex. So again, we're just going to need to find the time. If you just take a look at it, you'll know that your final velocity, of course, it starts out here at, well, we don't know. Do we? Actually, no. You're finding to the apex height, so you know that this ends at 0 meters per second, just as in part B. You know your initial velocity is 6 root 3. You also know that your acceleration downwards is negative 10 meters per second squared. And of course your height is just 5.4 meters. So basically at this point you can just use any formula that you want that doesn't really involve t a ton. But to simplify things, we're just going to use this equation. V equals V naught plus AT. Which is basically just the basics. So, let's start plugging in values. You know that your final velocity is 0. You know that your initial velocity is 6 root 3. And you know that your acceleration is negative 10. And then multiplied by t, you get negative 10t. So if you solve this, you get that 10t is equal to 6 root 3. And you get that t is just equal to 6 root 3 over 10 seconds. I'm not going to simplify that right now, but you can just plug that into your calculator and get some value. I'm just going to write that here as 3 root 3 over 5 seconds. And of course, the College Board isn't going to ask you a lot of qualitative kind of questions, which basically mean, actually quantitative, meaning that they're not going to ask you to solve out a lot of values. More likely, they're just going to ask you to like find and prove formulas, But I'm just gonna go over topics, like I said in the beginning of the video, that are like a bit shaky for kinematics. If you know these, you're basically an expert at it. So, we found how long it takes to reach the apex, but how long does it take to reach the ground now? Well, you know that from the apex, an object is going to move like this, right? Parabola. And we found that this was 60 degrees. Well, the apex is just right here. If you just eyeball it, take a look at it for like 3 seconds. Something cool appears, right? You think that this length right here is the exact same as this length right here. And in actuality, you are correct. So what does that really mean? That just basically means you can reflect that over to make it this. What else does that mean? The time it takes to get to here is the same amount of time that it takes to get to here, which means that your answer to part CII is also 3√3 over 5 seconds. And if you don't believe me, you can go do the exact same thing here. You know that your initial velocity here is going to be 0 instead of some random number because you're at the top staying still. You don't know your final velocity yet. You know that your acceleration downwards is going to be positive 10 this time, since you're going to go moving down. And you know your distance up, because we calculated that already. If you moved 5.4 meters up, you need to go 5.4 meters down. So,
wait, I have a question.
Mm-hmm.
Why does the time to reach the apex the same to reach for the end? Does that mean that the apex is the end?
No. Like I said before, this is just a reflection over. This is actually exactly halfway. And again, if you don't believe me, you can just take a look at this right here. Like, watch. We're going to find time now, right? So what is time? Well, I mean, technically it's going to be easier to just find final velocity first. But if you really want to, you can just go and figure it out here. So you know that your change in x is equal to v0 t plus 1/2 a t squared. Squared. Right? So
What I
just plug in
really
values.
don't get is part C is asking you to find the time it takes to reach to here.
Mhm.
But then part II tells you how much time it takes to reach to here.
Mhm.
Why is the time the same?
Like I said, it's quite simple. Think about it like this. If you moved all the way up here, it took 3√3 over 5 seconds, right? If it took you that long to go up there, it's going to take you the exact same amount of time to go down here. You can find that out with 2 ways. You can either think, oh, it's just symmetrical. If you flip that over, you're going to see that this blue part right here is just the same thing as the green thing right there. It's just reflected over this line right here. Or, you can go the more derivative route. You can solve for the time here. So you know that this is 5.4. And you know that that's equal to 0 plus 1/2 times 10 times t squared. So if you just multiply that over, you get, well, that's 10. That's just 5, right? Because 1/2 times 10 is 5. And then you multiply that over, so you get, what is that? 27 is equal to t squared? Actually, no, wait, that's not right. You're dividing by 5. So it's just 5.4 over 5 is equal to t squared. So t is just the square root of 5.4 over 5. What do you know? If you were to calculate that, you're going to find that the square root of 5.4 is the same as 3√3. Surprising, right?
Isn't there a square root here as well?
Good point. Sorry about that, I did not see that. See, it's technically a square root of 5 is what he was saying. So if you just like rationalize that, you're going to get that the square root of 5.4 times 5, which is 27. Do you understand how I got that? It's just 5.4 times 5. If you calculate that, that's just 0, that's 27, you add a dot, so you get 27. Let's say you got 27 right there. It's basically that over 5, because you multiply root 5 times both sides. That simplifies to 3 root 3 over 5. What do you know? They're the same. Symmetry, or you can find it yourself. Of course, this way is much faster, but just so you know. So, basically, if you find how long it takes to get to here, you know how long it takes to travel the entire path. Which is 2 times this, because you need to go up and then down. Which means you're going to go, it's going to take you 6 root 3 over 5 seconds for your entire trip. Of course, they're not asking you that, but the AP College Board is probably going to ask you that on an exam. Right, so, fairly simple, right? Just clear some space here. Alright, the final part. You're almost done. They're basically asking you to find the total displacement. So what does this mean? Total displacement. Well, we know that displacement is how far you got from your initial point. So maybe I shouldn't have to destroy that painting earlier. But if you take a look at this, your total displacement is essentially this point all the way to this point. What is this distance right here? This is what they're asking for. So what is it? It's quite simple, actually. We know our initial velocity is 6. Since we launched it, is there anything affecting the horizontal velocity? If you find it, no. Your answer is no. Your initial velocity is going to stay 6 for the entire trip. It's always going to stay 6. Here, it's going to be 6. Here, it's going to be 6. And even here, it's still going to be 6. Meaning, we can just use VEET, which is a memorization pseudonym. Well, it's I guess just a mem tactic, you know? It's just V is equal to acceleration. Actually, no, let's not use that. Not V. It's just velocity or speed is equal to distance, displacement, divided by time. And we're just trying to find how far it traveled. In other words, our displacement is just our velocity times our time. So, we know our velocity, 6. It stays 6 the entire time. So we can just write that as 6. But how about our time? Well, if you can recall from our previous lessons, we know that from here to here, it took twice this time, or, as we wrote before, 6 root 3 over 5 seconds. And if you don't understand why, just add these two together, or just multiply this by 2. So you get that your entire flight time is 6 root 3 over 5 seconds. So how do you calculate this displacement? Simple. Just multiply that together. So you get your final answer is 36 root 3 over 5. Again, I can't calculate that right now. Meters. Always, never forget your units. Units can be a killer if you do not write them down. They will take off points for not writing a unit, so never forget that. That's a quick tip right there. But yeah, 36 root 3 over 5 meters. That's your total displacement. Alright, that was Kinematics 101. You got all these concepts, you're essentially done studying for kinematics. Ever have a test to study for? This is the best way to study. Just come up with a question that comes up with these 5 topics right there, and then study those. If you can get all those down, you're good to go. Alright, that's all. See you guys later.